Hello friends, in this video tutorial, let us see data mining techniques in SSAS. Namely, we will see three techniques: decision trees, clustering and neural networks. And we will also see some of the other features in SSAS by which we can compare these techniques and their prediction abilities for the given data set. Okay, and we will see how to query using DMX by generating queries from our model. So for the purpose of this video tutorial, we will be using this database, that is SSAS 2014. As we can see, currently right now it has got only one data mining related database, and that is data mining 1. Okay, now for this tutorial, let us first of all create a new project. Okay, and let us create it as data mining 2. Okay, and let us name the project as data mining 2. Okay, and we will be creating a project for data mining, that is the first option, analysis services multidimensional and data mining project. So let us click OK. So now our blank project has been created. Now let us first of all create a new data source. So we'll point it to our database. We will be using SSAS data mining database. We will be using service account. So now DS is created. Let us create data source view. So in this we will be using the view called v target mail. Okay, this is one of the standard databases like AdventureWorks. Okay, so we will be using this v target mail view. Let's click next and let's call this as DSVS. It's a data source view. Let's click finish. Now let's go to our database. So this is the database, data mining, SSAS data mining is the database. Inside we have got views, and the view that we are going to use is v target mail. So let us see what is the structure of the data returned by this view, and we can see that there are multiple columns for customers. Okay, there are multiple details about customers, and the last column is bike buyer, whether this customer is buying a bike or not. Okay, so we will use this data. Now over here, let's go to mining structures and create a new data mining structure. So we will be using existing data table or view. Next, now for this video tutorial, let us use the second method, that is decision trees. In one of our earlier video tutorial, we have already used time series, but in this video tutorial we are planning to use three methods, that is we will be using clustering, we will be using decision trees, and we will be using neural networks. Okay, so let us first of all start with decision trees. Let's click next. Now this is a input data table, so that's why we will have this case checkbox as ticked. If we have multiple tables and if there are some other tables which are related to the input table, then we can call those other tables as nested tables. But in our case, there is only one input table, and that is a view, that is v target mail. So we'll have the checkbox for v target mail for the case column checked. Now let's click next. So over here, the wizard has automatically selected customer key as the key, and it is the right key. Okay, now we need to first of all define what we want to predict. So we want to predict the buying behavior for the bike. Okay, so let us click over here, which means we are going to predict bike, whether the customer is a bike buyer or not. Okay, now which are the factors that are affecting the bike buying behavior. So age will be an input, it will be a factor. Then date of birth is not required because age covers that particular data information, that is date of birth and age are related fields. So we will not select date of birth. Commute distance is definitely a factor. Then date of first purchase can be a factor. Email address will not be a factor. English occupation and education both are factors. Then gender is a factor. Instead of geography key we will take this region. Okay, so let's not take geography key. House on the flag is definitely a factor. Whether a person owns a house or not, that may determine whether he is buying a bike or not. Now marital status is definitely a factor. Then name, style, cars, number of cars owned is a factor. Number of children at home is definitely a factor. Region can be a factor. Let's put education, occupation, let's say. Okay, and total number of children and yearly income, these are all the factors. Okay, so let's click next. So it is giving us that customer key is the key and the data types are either discrete or continuous and they have been correctly picked up. So let's click next. Now this is very important. We want to keep the testing set to 30%. So 70% will be utilized for training set and 30% data will be utilized for testing set. So let's click next. Now let's call this as mining structure, and this model we are using, this one is for decision tree. So let's give the proper naming of the mining model also. Decision tree is the name. Allow drill through and finish. So now we have a model created. Okay, now before processing the model, let us go to the second tab, that is mining models. Now over here it is already showing us for first model, right? This is the decision tree. Now let us add two more models. So add new mining model, and this time we want to add clustering. So let us call this as clustering. Okay, so it has added another model, that is clustering. Let's add third model, and this time let us call it as neural network. Okay. Okay, let's click OK. So now we have three models added. Okay, so now let's go and process, but before that we will require the connection name for this SSAS database, okay, where we want to deploy. So this is the database where we want to deploy, and we can see right now there is no database called SSAS data mining 2. Okay, so let's go to the deployment settings. Let's provide the path of the server. Okay, and remember that the database name over here is SSAS data mining 2. So the new database which will be created will have this name, that is SSAS data mining 2. Okay, configuration settings, these two checkboxes are ticked. Apply. Okay, now you can process. So now processing is happening. So now everything is processed successfully. So let's close everything. Let's go to database. Let's refresh and check that whether the second database has been created or not. And we can see that the second database with the name SSAS data mining has been created. So now let's go and see the things details in the database. So we have the data mining DS, DSV, and for the mining structure we have now three mining models, right? So everything is there. Now let's go. Now we have visited the first and the second tabs, right? The first one is for structure, second is for the mining models, right? So let's go to the third tab, mining model viewer, right? So see what is happening right now. It is showing us that this is decision tree. First of all, the mining model, first mining model out of the three which has been shown on the screen is decision tree. Okay, and it has generated the graph for the decision tree. Now by default it has shown three levels, 1, 2 and 3, because over here the default expansion is up to 3 levels. We can make it all levels also. Okay, so now it is showing all the levels. Okay, fine. Okay, now how to read the graph? See, where the data density is more, that particular portion will have thick violet color, and where the data density is less, it will have light violet color or white as the color. Okay, so this is the way the graph is showing data. So first of all, let's go to 3 levels so that we can understand the graph in a better way. Okay, so now what it is showing is that out of all the data, the date first purchase having date between this particular range, okay, we have 8501 cases. Okay, it is shown in the tooltip, whereas the first there are three parts, right? There are three paths, out of which the first path has something around 3200 cases, the last path has around 800 cases. So the significant part is the part or the path which has got 8500 plus cases. So most of our data cases are lying in this path, which means for this particular data is showing that for all these independent factors combined together, there is a lot of data which has got similar characteristics. Okay, so we need to traverse this path, then to this path. Okay, then we can similarly keep on traversing the path. Okay, so over here, then we can go over here, right? So how to read this? So which means, first of all, there are lot many customers which have the first purchase date between this range, right? And then out of them, out of this 8500, there are around 5300 customers whose age is between 43 and 78. So they are forming the main portion of our buyers. Then out of them, there are customers who are having less than 3 children, which are the majority ones. Then even if we traverse further, we find that out of these customers, the customers having yearly income between 58,000 and 74,000 are the majority ones. So this is our most probable set. These are the people who are buying the bikes. Okay, and this, if in future similar customers with similar profile come, then they might be our main potential customers. Okay, so in this way we need to read the data, and we need to read this data up to all levels. Okay, up to the final level. Okay, so this is the way in which we interpret the graph for decision trees. Now in the decision tree there is also second tab, and this second tab is for dependency network. So if we go to the dependency network, see, it's right now showing that this bike buyer behavior is actually dependent on all the factors. But now let's go to the last column. So as per this algorithm, date first purchase is the main factor that is affecting. Then second factor is number of cars owned, then age, then number of children at home, then yearly income, then commute distance, then region, marital status, English occupation, English education, house owner flag, total children, and gender. So gender is the least factor affecting this behavior right now. Okay, so this is the way in which we can use the second tab, that is dependency network tab, to understand the impact of the individual factors on the behavior that we are looking for, that is the bike buying behavior, right? So this is the way in which we go through this first type of model, that is decision tree. Let's go to the second type of model, which is clustering, right? So if we go to clustering, it is showing us where the data has been clustered. So it has automatically formed around 9 or 10 clusters, and this data, the cluster which has got the maximum data is having thick violet color, right? And the cluster which is having lesser data is having light violet color, or maybe if it is having no data, then it tends to go up to white color. Okay, so the density of the color determines how much data it has. So obviously cluster 1 has got the maximum data, okay, that we can see. Okay, so and least data is with cluster 10. Okay, so population is 438. For cluster 1, population is 2137, that is 2137. And the cluster 1, which is having the most darkest color, okay, is constituting nearly about 17% of the data. Okay, so we are interested in the characteristics shown by the data set within this cluster, that is cluster 1, to determine which are our potential buyers, right? Similarly, we may also be interested in looking at cluster 10 to understand which are the customers which we should avoid for our marketing efforts, because maybe marketing for this kind of customers may not yield results, right? Because they have not been buying bike in past. Okay, so for such customers, advertising or marketing revenue spend may not yield results, right? So that's why cluster 1 and cluster 10 are important for us. Let us now understand. So this is the first tab inside clustering. Now let's go to second cluster profile. So now we can see that all the clusters have been shown over here. Also, every influencing factor is shown as the rows, and on the columns we have all the clusters. So if we want to study the first cluster, that is cluster 1, then we have to go vertically in this particular column for cluster 1. Now if we hover the mouse over here, it will show in the tooltip the characteristics of the data. That is, for cluster 1, the majority of the customers are in the age range of 52.55 plus or minus 6 point something, right? So the age range is nearly 46 to 58. Okay, then similarly we can read other attributes like commute distance. If we click, then it will show in this particular table also that what is the characteristics of the data shown. So the maximum number of the bike buyers are either having commute distance of 2 to 5 miles or 5 to 10 miles. Okay, so that is, so if the distance is too high, then also the data is let's say if the commute distance is less than 1 mile, then there are not many buyers. Okay, so now let's go to third, and let's say English occupation. Okay, so it shows that professionals are the people who are buying the bikes the most. Okay, now gender, so it's a kind of it's similar data for male and female, so it's not affecting for the cluster 1. Okay, house on a flag, it's a significant factor for cluster 1, because if the person is owning house, then he is having more probability of buying the bike, as shown by the 75% probability. Whereas if he is not owning the own house, then the probability of buying bike is 0.24 only, that is 24% only, right? So in this way we can understand the influence of each and every independent variable or the factor on our current cluster under consideration, right? So in this way we can study. Now also we can go to cluster characteristics. So this is data for all population. So as per this particular uh, clustering method, house owner flag is having highest influence, okay, on probability of buying a bike, okay, and that is 67%. So if a person owns house, he or she is having 67 percentage probability of buying a bike. Also marital status, if the person is male, then he is having higher probability of buying the bike. Also if the gender is male, or if the region is America, North America, then there is higher probability of buying the bike for the whole population. We can similarly understand the distribution of data within a given cluster also. So if we want to study only cluster 1, then the occupation is having major influence, okay, that English and Spanish occupation is having major influence. Both have the same percentage exactly, because they both have exactly the same data. Then house owner flag is also important, region is also important, marital status is also important, okay. So these are the key factors for determining the buying behavior of a person for the people who are part of, or the cases who are part of cluster 1. Now this is also a very important tab, the fourth tab for clustering, that is cluster discrimination. Now over here what we are saying is, when we are comparing data between cluster 1 and complement of cluster 1, meaning rest all data, okay, this data is for cluster 1 and cluster 2 constitutes all other data other than cluster 1. So how is the buying pattern over there? So this means that if occupation is professional, then it favors cluster 1, which means then the people are buying bike. Whereas if occupation is management or clerical or administrative or manual, then they are favoring cluster 2, that is complement of cluster 1. That is, it means that they are then not buying bike, they are falling in the other cluster, okay. So this first cluster has got data mostly related to people having profession of occupation of professional, whereas all other clusters are mainly having data related to other professions. So in this way we can go through or study the data for the fourth tab also for clustering. Now the only method remaining is neural network. So let's go to it. It has got only one tab. Now let us understand what it's trying to tell us. Value 1 is having probability from 0 to 16%, and value 2 is having probability between 16 to 50%, okay. So what we are interested in is, we are interested in the highest probability. So we are interested in 84 to 100% probability and 16 to, let's say, lowest, okay, 0 to 16% probability. So where are our customers having attributes for these two kind of probabilities? So we can see that if the house owner flag is 0, then, and let's go by this. So if the house owner flag is 0, then it favors 0 to 16%. So that person is having very less probability of buying a bike, okay. And similarly, let's go by this. If yearly income is between this range, then that person has got one of the highest probabilities of buying a bike. So, okay. Similarly, let's say if children are between 1 and 3, then that person has got very high probability of buying a bike. Also if the region is Europe, then the probability of buying a bike increases a lot, okay. Also if the age is between 29 to 39, then there is very high probability of buying a bike, okay. If the number of cars owned is between 0 to 0.73, that is 0 or no cars, then the person is having very high probability of buying a bike. So in this way we can interpret this model, that is neural networks model. But now we may also be interested in knowing that we can see that we can do data analysis on this particular data set using 3 methods. In this case we have used 3 methods. Now for this particular given data set, which method is having a higher probability of predicting? Because see, if the data set changes, then some other method may yield us better results, okay. But for this given data set, which method is having higher probability of yielding us accurate results? So for this, let us go to the third tab. Right now we were in the second tab of mining models. Let's go to we are in the third tab, that is mining models viewer. Let's go to the fourth tab, that is mining accuracy chart. So this will compare the methods. So it's telling us that there are three methods under consideration, and we can go to lift chart. Okay, so this lift chart is telling us that the score of neural networks is for prediction is highest, that is 0.98, and 1 is the highest possible value. So it is very near to the highest possible value, and the decision tree is having least value, and clustering is having 0.75. So which means neural network method for this particular data set is having highest probability of predicting accurate values. Okay, now let's go to database. In database, if we go to mining structures, mining models, okay, let's say we go to the clustering or decision tree. Okay, then we can see the similar view lift chart over here also. Okay, so it shows the same screen. It has got three methods, and if we go to the lift chart, it shows the same data, that is neural network has got 0.98 probability, followed by clustering having 0.75, and last is decision tree having 0.00, right? So this is the same data. Okay, now let's go to SSDT again. Now let's go to the last and the fifth tab, that is mining model prediction. Now this we already seen in our earlier video tutorial. So let's go and see how to use it further. In last video tutorial, we had used this tab to generate a query. Okay, to generate a DMX query which can query data from our model, SSAS model, right? But now that is mining structure, right? But in this case, we want to use it differently. Now whatever we have done till now is actually forming the training data set. Okay, we have training an algorithm like decision tree or time series, or let's say clustering or neural network. These are all algorithms of data mining, and what we are doing is we are giving it a training set, and with the help of this training set we are training the algorithm to predict the data for us, right, for in future. So now after the data training set has been given to our algorithm, and after that algorithm has been trained for our training data, we also need to go to the next step, that is we also need to predict the data for the fresh data, incoming data, right? And for the fresh incoming data, we want to predict for every customer, looking at their behavior or looking at their characteristics and attributes, whether this particular customer, that is new customer, is a potential buyer of bike or not. So for this, and right now I don't have any new data, so what we will do is we will select the same table, that is customer table on which the view is built, right? So we let us select this customer, and let us pass this data of customers through this model, okay, and through this prediction. So and let us see what all values it gives us. So let us now form the query. So dim customer table dot customer key, customer table dot, let's say, first name, or let's say email ID, because we want to email the potential buyers, right? We may want to send a let's add advertising campaign related email, right? So to the potential buyers. So let us select email address, correct? And let us select customer's first name, correct? And let us say what we want prediction function, and we want to predict the probability of buying a bike by the customer. So what we want to predict? We want to predict decision tree dot bike buyer behavior, right? So this is enough. This will give us a query and a result. So this is the query. Let's Control A, Control C. Let's go to database. Let me close this. Now if we go to database, right, we can create a new DMX window. Over here we will paste the query. If we run the query, it will give us the probability of buying a bike for all the customers in the dim customer table, and we can see that different customers have got different values, right? See, this value and this value are obviously different, correct? Also this value is 998, others are generally 999, correct? And let's say, right, so there are different values for different customers, correct? So now let us go and do one thing. We are interested in finding customers which has got probability of 0.999 or higher. So we don't want any customer having 998 or anything less than it, or like this, right? 0.962. We don't want these customers. We only want customers having probability of 0.999 or higher. Okay, so right now let us see in this SSDT also whether we are getting data or not. So we have gone to design tab, and we have using the design option, we have designed the query. We can see the query over here, and the last thing is we can see the results also right from SSDT. So it's giving us the same results, right, having different values, right? So let's do one thing. This is the complete data, correct, without the where clause. So let us add a where clause. Okay, so this is the column on which we want the where clause, right? So let us copy it. Okay, let us put a where clause where this is greater than, let's first of all see the data which we don't want. Okay, so 0.999. so if it is less than 0.999, we don't want that data, right? So let's execute. So we can see there are a lot of data which is having the values of probability less than 0.999. like this is the data, right? 0.962, right? And 998, right? So all such data is present, right? Also we have 0.9375, right? These are all the data which we want to avoid, correct? So let us change the condition to greater than, correct? So now it will only show us the data which is having probability greater than or equal to 99, let's say equal to, okay, or equal to 999. So let's execute the query. So now we have all the data for which probability is higher, and we have the particular email IDs also, so we can send marketing emails to these particular customers as they may be the potential buyers, correct? So in this way we can use this data mining, right? So I hope friends this video tutorial on SSAS data mining using the mining models of decision tree, clustering and neural networks is useful to you. Thank you.